Introduction. Hello, engineering enthusiasts. Imagine if you could just reach out and catch sounds, images, and data floating around you. Well, that's essentially what an antenna does. The role of antennas. Antennas, whether they're metal rods or dishes, pick up radio waves in the air and turn them into electrical signals. Those signals power devices like radios, TVs, and phone systems. Transmitters versus receivers. Usually we think of antennas receiving signals, but there are also transmitting antennas. Transmitters take electrical signals and convert them into radio waves, sending them across the globe, or even into space. Modern telecom essentials. It's thanks to antennas and transmitters that modern telecommunications exist. But how do antennas actually work? These principles stem from James Clerk Maxwell's 19th century work on electromagnetic theory. And today, this knowledge is fundamental for devices ranging from home Wi-Fi routers to deep space probes. Whether you're streaming music or making a call, antennas are handling the signal. Basic transmission. Picture yourself running a radio station and wanting to broadcast worldwide. First, you convert voices into electrical energy using microphones, creating radio waves. That energy is fed into a large metal antenna. As electrons oscillate back and forth in the antenna, they emit invisible electromagnetic radiation. Radio waves. Speed and propagation. Those waves travel at the speed of light, carrying your program. When they hit a receiver's antenna, they make its electrons oscillate, recreating an electrical signal that turns back into sound. Similar designs, opposite functions. Although transmitters and receivers do opposite jobs, they often look very similar. A single antenna can both send and receive, as in satellite phones. Parabolic dishes. Take the parabolic dish. Its bowl shape, technically a parabolic reflector, focuses signals precisely, whether sending or receiving. Size differences. Radio and TV broadcast antennas are huge to cover long distances. Home antennas are much smaller since they only need to pick up nearby signals. Frequency matters. How waves travel depends on frequency and distance. Those factors also dictate antenna size and type. Antenna length. Generally, bigger antennas pick up signals better. A simple piece of wire can act as a rudimentary antenna. Modern radio antennas. Most portable radios have two, a telescoping rod for FM and an internal whip for AM. Why two antennas? FM and AM use very different frequencies and wavelengths, so each needs its own antenna to work well. AM versus FM. AM waves oscillate much more slowly than FM, giving them longer wavelengths and requiring different antenna sizes. Wavelength proportions. An antenna is ideally about half the wavelength of the signal you want to catch. But modern tech lets us build antennas at a quarter or even a tenth of that length. Tuning and resonance. If an antenna were fixed length, you'd only receive one station. Tune circuits let you focus on one frequency and ignore the rest. Simple receiver circuit. A basic radio circuit uses a coil, a diode, and a capacitor to select a station and convert it into audio. Importance of resonance. The antenna must feed enough energy so the circuit resonates at the desired frequency. Otherwise, your station won't come through clearly. Antenna formats. Some antennas are just straight metal rods, monopoles. Dipoles, two rods like outstretched arms, are common in TV sets. Advanced designs. Outdoor antennas combine multiple dipoles or loops, and there are even more exotic shapes for special purposes. Why so many designs? Different shapes help focus and amplify the same incoming waves in various ways, improving reception efficiency. Directors and reflectors. Some setups use extra elements, called directors and reflectors, to steer more signal into the active parts of the antenna. Key characteristics. Every antenna is defined by 3 traits: directivity, gain, and bandwidth. Let's break them down. Directivity. Dipoles are very directional, so you must point them just right. That's why early TV viewers spent ages tweaking their antennas. Modern digital TV. Digital signals have made this less of a headache, but precise alignment still helps when the signal is marginal. Exceptions to directivity. FM telescoping antennas work well from most angles if the signal is strong. Ferrite bar AM antennas, however, need careful orientation. Pros and cons. A directional antenna can reject unwanted interference, but mobile devices need to pick up signals from any direction. Mobile antennas. Cell phones and GPS receivers must handle signals arriving from all around, so they aren't highly directional. Antenna gain. Gain measures how much an antenna boosts a signal. It's expressed in decibels. dB higher gain means better reception. TV reception example. Even without an external antenna, a TV set's metal chassis grabs some signal. Add a proper directional antenna and reception improves dramatically. Comparing antennas. Outdoor antennas almost always outperform indoor ones. Window-mounted sets do better than built-in antennas. Bandwidth. Bandwidth is the range of frequencies an antenna handles well. A wide bandwidth is perfect for TV, where you need multiple channels. Narrow versus wide. Communications gear, like satellite dishes, only needs a narrow bandwidth tuned to one frequency. Closing call to action. If you've stayed with me this far, don't forget to subscribe, like, and hit the bell. Want to support the channel even more? Become a member. Career Growth Plug. Looking to boost your personal or professional skills? Check the QR code or the link in the description for opportunities that can propel your career. Final curiosity. By the way, what engine oil do you use in your car? Ever tried it on door hinges? Drop a comment. I'd love to hear your experiences. Recommended videos. 2 videos are waiting for you on the side. Go ahead and keep exploring engineering with us. Farewell. That's it, engineering lovers. Big hug, and I'll see you in the next video.